Hello and welcome back to a fraction of MHM. Today I'll be looking at the 2018 November paper for the IB Standard Level Mathematics. This is paper 1, question 1. Let's get going. Find the area of the shaded sector. Now I've written a couple of notes here just so that you've got those formula with you. I'll go through how to get to them at the end if you didn't already know them. But for now, it's plug and play for the first part. So the area of a sector, check that the angle is in radians. You've got it in radians, so it becomes 2 over 2 times by 6 squared, which is going to equal 36. So the length is going to be, the area of the sector is going to be 36 centimeters squared. That part's complete. Now the trickier part is part B here. Find the perimeter of the non-shaded sector. That's going to be this bit here. There are a couple of approaches to doing this. What you could do that the IB recommends is to take this angle, find the arc length, and then just add those two values on. That's certainly a possibility. The other option is you find the circumference of the whole circle, take away that length there, depending on whatever you find easier to work through. I personally find doing it the second way easier, but I can see why the first way makes more sense. So we'll have a look at that quickly, and then at the end, once I've answered both, I'll go through the derivation and the other way of doing it. So for this one, you have to know that a circle, or 360 degrees, is the same as 2 pi radians, which means the angle that of the non-shaded region is actually 2 pi radians take 2, because we're not going to include the shaded angle of 2. Then we apply this to our arc length formula. So this is our A, we times it by R, which is 6 in this case. That'll give you 12 pi take 12 for the arc length. Now you want to add on the 2 extra values here for the radius to make the non-shaded region, which becomes 6 plus 6, which simplifies to the perimeter of the non-shaded region being equal to 12 pi centimeters. And that's that. So, how to do it the other way? So the other option, more steps, but I guess in a way it could be easier for some people. Depends on how you think, really. You look at the circumference of the entire circle. So the circumference of a circle is pi r squared. We know that. You should know that. If you don't, there it is. That's the area of a circle. That's an area of a circle. Circumference of a circle is pi d. Wow. There we go. Pi d. D in this case is 2 times the radius, if you didn't know that. So I was thinking of 2 pi r, as soon as we'll work in what we've got already. So that's our circumference of the circle. And we want to take the value of the shaded region away from that to basically get what will effectively be this part here. So taking that value away, you've got r times a, which is 6r. Sorry, 2r, which is 2 times 6. So you've got your 12 already, and your 2 pi r becomes 6, and then you're straight back to here again, because 2 times 6 is 12. So you can do it that way if you like. The difference is knowing that there's 2 pi radians in a circle, or knowing the formula for circumference. Doesn't really matter either way. Similarly, the area of a sector can be derived from the area of a circle formula, which is what I was talking about before when I got sidetracked by my own brain. So again, this is just extra stuff. The question's done. This is just extra knowledge for your own understanding if you're interested. So we take our formula. We'll start. I'll come down here a little bit. So I've got the formula theta on 2. Theta is going to represent the angle now, times by radius squared. That's the area of a sector. So we just want to compare that to the area of a circle, which is pi r squared. Okay. Now, if you think about a sector, it's really a segment of the area of the circle. So what you do is you take this angle here, which is in radians, and basically substitute it in. So this is effectively like saying, if you did it as part of your formula, if we did this all expanded out, if I wanted to find the area of a sector that was an entire circle, I'd be working with 2 pi radians divided by 2, because this is our theta for a complete circle is 2 pi. So that would be this section here. You divide it by 2 comes from this formula, and then you're left with your r squared from both formula. And you can see how, because we're working with a whole circle, that simplifies out to get you back to this step. So it's a little bit, they're really the same formula, but done in different expressions, so you can tell the difference basically and actually apply them. But if you take, it's a bit of funky rearranging here, so you have to take out 2 pi from this bit, which leaves you with the gap for where it should be, the theta angle divided by the 2, which is what cancels that factor out, and your r squared. And that's that derivation. Just in case, you know, it happens to help you remember, you don't have a formula book, anything like that, that's how you get that derivation. Alright, thank you for watching, everybody. Tune in for the next one, and as always, any questions you have, please drop them below. Not necessarily about this question, but any problems you want me to solve, I'll have a look at them, and if I feel confident enough that I can give you the correct answer with the correct working, I'll make a video on it, and I can tag you and give you a bit of a shout out in the title. Alright, see ya.